Hey guys, so notice that a lot of people were having issues with this assignment as well. So I want to take a moment now that everybody's kind of had a chance to look through this and at least attempt it, so that we can kind of go over how this is actually supposed to work. There we go. Um, okay, so this is our 3.03 in-class returns, and this is kind of part of the entire unit on functions. And this is going to be one of the first times we were working with returns. So in here, we've got a prompt that says, we're going to write a function that's called flip coin. It takes in no parameters, but it returns a string heads 50% of the time and a string tails the other 50% of the time. And it's saying that we're going to use random.random specifically, and this is because we wanted to have, I think we'd be using random.randint a bunch, and this would be time to use another different function here. So there's a link to how this works in the documentation. So second requirement here is that we are going to declare two variables to count the number of heads and tails observed. Okay, those can be anything you want. Doesn't matter. The last thing here, or last two here, we're going to call our function flipCoin 10 times, and we're going to count the number of heads and tails observed. And then we're going to print only the total counts observed, and here's an example of what this output is supposed to look like. So I'll zoom in a little bit here just so we can kind of see this a little better. But there we go. So I'm going to kind of pop into my IDE here. I've got all this stuff already copied over. So let's kind of take this like one at a time here. Okay, I guess that did not copy certain things. So we're going to write our function called flipCoin. So how do we write a function? That's using this def keyword. So define, and then we've got our function name, and it says that it takes in no parameters. So we don't have to put anything in the parentheses here. And then we can just put our colons and start our function. So we know that it's going to return something 50% of the time heads, 50% of the time tails. And we want to use random.random. So another thing that we have to do, and we're going to import random, because that's the library that we need to use in order to actually gain access to this function of random.random, or which is random library's random function. Okay. It says we're going to declare two variables to count the number of heads and tails observed. So we'll get to this part first, and we'll deal, okay. We're going to return 50-50, right? So basically this is supposed to simulate a coin flip. So let's just have a variable flip, and we're going to call it, or say, this is random.random. So remember, this is going to be some sort of float from 0.0 to 1.0. And then, so 50% of the time would mean that if this is 0 to 0.5, we're going to do one thing, and 0.51 to 1.0, basically, it's going to do another. I know that's not perfectly, going to work out, but it's close enough that it doesn't matter. So what we want to do then is say that if, because this is going to be a conditional, right? So we need to make sure that if this is above a certain threshold, we're going to do one thing. So if flip, which remember is going to be some sort of float, is greater than, let's say 0.51, we're going to just, it says we're going to return a string heads or a string tails 50% of the time. So we're going to say heads, and it says it's all caps. Otherwise, and remember, we already know that this is, if it didn't succeed here, we don't need to check that it was less than 51. Like, that's the only other option, because this can't do anything else. So else we're going to return tails. And this is actually one of these cases too. So if it failed here, this doesn't run. So we don't really even need this else statement. We can just chop that off and do this. And that's satisfying this 50-50 ratio. Because if flip randomly generated like 0.6, then we're going to return heads, and because we return, we immediately get ejected out of this function, and it's returning heads. So this tails never gets reached. This is unreachable code at that point. Is this going to tell me that this is, oh, never mind, different error. If this fails, then this returns. And so that means that either case, one of the things you want to check for in these functions is that, if this is expected to have a return, you want to make sure that every possible route has a return. So yeah, both this function is going to return one or the other every single time that you call it. So we're also going to declare now two variables that count heads and tails observed. So I don't know, let's just call them like heads count, and we're going to probably want these to be starting at 0 because we haven't flipped any coins yet. Okay, now we're going to call our function flipCoin 10 times and count the number of times that we see heads or tails. So down here in our global scope, we're going to just have something. How do we count something or do something 10 times? That's a good candidate for a while loop. I mean, you can do something goofy, like we could say flip coin, flip coin, flip coin, flip coin. But that's a lot of redundancy. And if we told this, if this was supposed to be 100 times, that would get super, super tedious. So instead, at this point in time, you should only have know the while loop. So we're going to start out a counter here. I don't know, we'll call this actually something more human readable. So we'll call it coin flips. And that starts out at 0 because we haven't flipped any coins. So while coin flips is less than 10, because this is going to go from 0. So it starts at 0, which means that it's including that. So the very first flip is going to be the 0th flip, which is kind of weird because that's just how programming works, right? Everything starts at 0. And it's going to be, as long as it's less than 10, so this would be counting for cases 0 through 9. And if you offset that, then that's like saying 1 through 10. So this is exactly the number of times that we want to be flipping. So every single time we are going to, let's see, like, I don't know, we'll call this like temp flip or something, right? And so we're going to call flip coin. And so when we call this, flip coin runs, and it's going to return a string, which means that we're going to store that string back into temp flip. So right now we can also just print this and just demo like what this is doing. So let's just run this right now and just see what this, or we'll, I'm going to have an infinite loop here if I don't increment this, right? Because if this starts out as 0 and never gets incremented, it never gets closer to the case where this while loop stops running. So this will just run infinitely until I get a Stack Overflow because my code is just going to go insane. Or maybe my computer can handle it, I don't know. But I don't really want to find that out. So what I'm going to do is coin flips plus equal 1. And so that's, again, just shorthand. This is the same thing as coin flips is equal to coin flips plus 1. A lot of languages have this. It's a little bit more processing intensive, I guess. Like they have to have the ability to look ahead, but that's kind of a compiler's issue or like a system runtime thing, so you don't worry about it. But some languages have the support for this. So if we run this right now, here we go. So it flipped a coin a bunch of times, and we can see that this is clearly some random order. But yeah, but we need to be tallying those up at this point. We don't want to just print these out, but we can at least see that every time that we flipped this coin, it ran this % chance. So it came in here, did random.random, got a new value, check to see is this greater than 0.51. If so, return heads. If not, return tails. We do this 10 times, store that result back here, because what return is going to do is this function basically gets swapped out. So instead of seeing this function here now, this is either going to be heads or tails. It gets stored into temp flip. I print that out, so that's where we get all of this stuff, and then we increment this by 1, so we get closer to the condition that breaks this while loop, so we don't have an infinite loop. So now we don't want to be printing this. We want to be able to figure out which bucket we're putting these in. So that's going to suggest that we need to look for some sort of a conditional. So if temp flip is equal to heads, then we can say heads count plus equal 1. And since this only has two possible returns, we don't need to say elif temp flip is equal to tails, because there's only one other possibility. It's never going to generate something weird like, it landed on the curve or something of the coin. So we can just say else, and then we know that we're going to increment the tails count plus equal 1. And then obviously we need to keep our coin flip in here so that we keep incrementing. So at this point now, we're calculating all of this, but we don't have anything that's printing it out in this format. So let's just kind of like copy and paste this guy over here. And get rid of this. So I'm going to use control forward slash, which you can do that in REPL as well. And that just is the command to auto uncomment a bunch of stuff. So here we go. I'm going to print this guy out. Put my parentheses and things around here. Same here, because this is a pretty lazy way to do it. I mean, you could do this with all kinds of other stuff. Like we could print all of these out in one giant print, but this is a little bit easier. So let's use an F string here, and we're not going to print out 4 and 6. What we want to be printing out actually is going to be these global variables. So here we go. So we're going to print out heads count, and same thing here. We're going to, instead of printing out 6, we want to print out tails count. I'm just using autocomplete here because it suggests that, and you can just hit tab or enter or whatever. Something, it'll, every IDE's got something for that usually. And so there we go. And we don't need to do anything fancy. We've talked a little bit about global. So these are in the global scope, and since this while loop is also in the global scope, we don't have to worry about that. This guy is pretty much self-contained. It's not using any of these things that are in the global scope, so we don't need to put global anywhere to declare that we want to use the global version. We can just run this as is. So let's run this guy and just see how this runs. So we got heads and tails are 3 and 7, and it printed out in the way that we were expecting. If we run this a couple more times, see that these values change around. Sometimes they're the same because it just happens. It's randomness. 50-50 is kind of what the expected output would be statistically, but it's almost never the case, right? Or I guess it's an even amount of times it's going to be the case. But there we go. So we can see that every single time that we run this, it's generally going to give us something different. And so far we haven't had any crazy outliers like 1 and 9. But I mean, those cases can happen. There we go. So pretty much everything's going to be clustered around that smaller sample size of, things that are like 50-50 and then emanating out or something maybe. Or I mean, these are just random, so it could be literally anything. All right, so that's how this is working. Hopefully that helped shed some light on what was expected here. All right, signing off.